acids, bases, and salts. Classification of compounds into acids, bases, and salts make the study easier. Various substances of our daily importance contain these chemical compounds. The word acid is derived from the Latin word acere, meaning sour to taste. The sour taste of many fruits is due to an acid or acids present in them. For example, sour taste of lemon is due to citric acid, that of grapes is due to tartaric acid, etc. Bases are bitter to taste, and hence very few bases are present in edible compounds but form a variety of other products like soaps, detergents, and cosmetics. Salts possess a salty taste as that of common salt we consume in our daily life. Some salts are also tasteless, that is, they do not have any specific taste. Acids. Most of the acids present in foodstuff are mild acids, that is, they do not harm our body in normal amount. But all acids are not mild. Some of the acids are harmful and highly corrosive when such acids fall on our body. They produce burning sensation and even chars the skin. Hence, acids should be handled with care. Classification of acids. Acids can be broadly classified into two types: organic acids and mineral acids. Organic acids are those which are obtained from natural organic matter. Example, tartaric acid, citric acid, etc. Organic acids are mild and are present mainly in foodstuffs. Mineral acids are those which are obtained from minerals. Example, hydrochloric acid, sulfuric acid, etc. Some of the mineral acids are commonly used in laboratories. Acids are the compounds containing hydrogen ion, which when dissolved in water produces hydronium ion. For example, hydrochloric acid or HCl. Hydrochloric acid reacts with water to form hydronium ion and chloride ion. Bases. Substances which seem bitter to taste and soapy to touch are known as bases. But chemically, we can define them as: bases are substances which dissociate in aqueous solution to give hydroxide ion. For example, sodium hydroxide dissociate in aqueous solution to give sodium ion and hydroxide ion. Potassium hydroxide dissociate in aqueous solution to give potassium ion and hydroxide ion. Alkali. The bases which dissolved in water are known as alkali. For example, NaOH or sodium hydroxide, KOH or potassium hydroxide, and NH4OH ammonium hydroxide. Indicators. It is not possible to taste all substances to judge for their acidic or basic nature. Hence, some special type of substance are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators change their color when added to a solution containing an acidic or a basic substance. Thus, indicators can be defined as a substance which gives different color in acidic and basic media and helps to differentiate the two types is known as an indicator. Example, litmus solution. It turns red in acids and blue in bases. Types of indicators. Natural indicators. The chemical substances found naturally are known as natural indicators. Example: turmeric, litmus, China rose petals, etc. Chemical indicators. The chemical substances prepared in laboratory to differentiate acids and bases are known as chemical indicators. Example: phenolphthalein, methyl orange, etc. Natural indicators around us. Indicators, whether natural or chemical, play the same role. That is, to identify the acidic and basic nature of a compound. Actually, indicators are composed of dyes which change the color in different media, that is, acidic or basic. Litmus, a natural dye. Litmus is one of the most common and naturally available indicator. It is extracted from lichens, combination of alga and fungus. These organisms contain this natural dye which possesses different colors in different media, that is, acidic, basic, or neutral media. When this litmus solution is added to an acidic solution, it turns red, and when added to a basic solution, it turns blue. It possesses a mauve or purple color in distilled water. Turmeric, a natural indicator. You must have noted that if a vegetable falls on the cloth or fabric, it leaves a yellow stain on the cloth. If you put slightly soapy solutions on it, at first instance, it turns reddish-orange and then gradually it gets removed. The reason is that vegetable possesses turmeric powder in it, which possesses a natural dye of yellow color, and when this dye comes in contact with acids or bases, it changes its color. Thus, turmeric solution can also be used for distinguishing acidic and basic solutions. China rose as an indicator. Another natural indicator used in our daily lives is China rose. The dye present in the flower can be extracted with the help of warm water, and finally, the colored water extracted can be used as an indicator. Ionization. All ionic compounds are made up of ions. To simply explain it, we may say that a positive ion is attached to a negative ion with a strong force, and this force is known as electrostatic force. When the compound is dissolved in water, these forces get reduced and the two types of ions are produced which are responsible for turning the color of indicators. Thus, ionization may be defined as the process of splitting up a compound into ions in aqueous or molten phase. Ionic compounds. All compounds do not form ions. These compounds which are capable of furnishing ions are known as ionic compounds. Such compounds have the ability to conduct heat and electricity. They also have a tendency to change the color of indicator. Ionization of acids and bases. Acids are the compounds which are sour to taste and turn blue litmus red. But along with it, the most important property is that they ionize in aqueous solution to yield hydrogen ion. As soon as these positively charged hydrogen ions are formed, they combine with water molecules to form hydronium ions. Thus, in other words, we may also say that acids furnish hydronium ions in the solution. Actually, these ions are responsible for turning the color of indicators. Since these ions are not formed in dry state, thus dry salts and chemicals do not change the color of indicators. Bases are the compounds which are bitter to taste and turn red litmus blue. The most important property is that they ionize in aqueous solution to yield hydroxyl ions. But these ions are formed only in the aqueous media. Dry bases or dry compounds do not yield any ions. These hydroxyl OH negative ions are responsible for turning red litmus blue and color of indicators. Neutralization. The process in which an acid reacts with a base to form salt and water is known as neutralization. Acids furnish hydrogen ion and bases furnish hydroxyl ions. These hydrogen ions and hydroxyl ion react to form water. On the other hand, positive ion of the base and negative ion of the acid react together to form salt. Applications of neutralization. In agriculture, to remove indigestion, ant and bee's bite, sting of yellow wasps. In spaceships, disposal of factory wastes,